Have you ever wondered how a frying pan heats up on a stove, or how a hot cup of cocoa warms your hands? It all comes down to heat transfer. Heat energy is always on the move, flowing from hotter objects to cooler ones. This incredible journey of heat happens in fascinating ways, and one of those ways is called conduction. Imagine holding an ice cream cone on a warm day. You can feel the heat from your hand transferring to the cone, causing it to melt. That's conduction in action. It's the way heat travels through direct contact, passing energy from one molecule to another. Before we dive deeper into conduction, let's clear up the difference between heat and temperature. They're related but not the same thing. Temperature measures how hot or cold something is, like the reading on a thermometer. Heat, on the other hand, is the total amount of thermal energy an object has. A large pot of boiling water and a small cup of boiling water might have the same temperature, but the pot has more heat energy because it contains more water molecules. Conduction is like a game of molecular tag. When you heat one end of a metal rod, the molecules at that end start to vibrate faster. These energized molecules bump into their neighbors, transferring some of their energy. This chain reaction continues, passing heat energy along the rod. Think of cooking pancakes on a griddle. The hot griddle directly touches the pancake batter, transferring heat and cooking it to fluffy perfection. That's conduction making breakfast delicious. The rate of conduction isn't always the same. Several factors can either speed it up or slow it down. Material type. Some materials, like metals, are excellent heat conductors, while others, like wood or plastic, are insulators. Think about using a metal spoon versus a wooden spoon in a hot soup. The metal spoon will heat up much faster. Cross-sectional area. A wider path allows more heat to flow. This is why a thick metal bar will heat up faster than a thin wire made of the same metal. Temperature difference. The bigger the temperature gap, the faster the heat transfer. A scorching hot stove will heat a pan much faster than a lukewarm one. Length of the material. Heat has to travel farther through longer objects, slowing down the transfer. A short metal rod will heat up faster than a long one. Scientists use something called the Law of Thermal Conductivity to calculate heat flow. The formula is Qt equals Ka T2T1 per day, where Qt is the rate of heat flow, K is thermal conductivity, A is the area, T2T1 is the temperature difference, and D is the thickness. Understanding conduction helps us in many areas. From designing efficient cooking pots to developing advanced insulation for homes and spacecraft, it's a crucial part of science and technology that makes our lives better.